Hello everyone. In today's lesson we are going to be solving some percentage problems like we did in class. Just to remind everyone what we talked about in class, there are four different kinds of percentage problems. For each of them I use this chart that helps me to better plan out my data and know exactly what I'm looking for. Let's start with problem number one. It says, out of a class of 24 students, 25% are boys. How many are the boys? So in this kind of problem, first of all, it's the only kind of problem where this middle line that says change can be ignored. It doesn't play a part. In all the other problem types it does, but in this one it doesn't. So in this kind of problem, I have a total, which is 24, because the entirety of the class is 24. So before I take any percentage of that, the entire total is 24. After I take the percentage, which is 25%, we're going to have something. We don't know what. That's what we're looking for. So basically that's why I put X here, because this is the number of boys. This is what I'm going to get after applying this percentage, 25%. Now, how I find X is I take this cross product and it needs to be equal. So 100x needs to be equal to 25 times 24. Let's solve that. 100x needs to be equal to 25 times 24. Okay, so that means that 100x will need to be equal to 25 times 24, makes 600. So this is an equation I can solve with relative ease. If we remember from our equations how to solve these, I basically divide both sides by 100. So I get that x is equal to 600 divided by 100 is 6. Meaning that there are 6 boys in the classroom. And that's my answer. Let's move on to the next kind of problem. The next kind of problem, it says, I bought a jacket that normally cost 80 euros with a 20% discount. How much did I pay for the jacket? In this kind of problem, we know the starting price, we know the initial cost of the jacket before any discount was applied, and we know a certain change. In this case, it's a discount. In other cases, you might see a problem that says that the price rose for some reason. In this case, though, it's a discount, meaning that we're going to put minus 20 because the price fell by 20%. It's 20% less. 20% is what I'm not paying, so that's why we say take away 20. So what are we paying? We're paying 80% because 100 take away 80, 100 take away 20 makes 80. So we're paying 80%. So what we're looking for is how many euros is it going to be after applying the discount? Again, we take this cross product of 100 times x that needs to be equal with 80 times 80. Let's solve that. Again, 100x needs to be equal with 80 times 80. So 100x needs to be equal to 6,400. Again, divide both sides by 100, and what you get is x is equal to 64. So after applying a discount of 20%, we get that I will pay 64 euros. This field does not need to be filled out. It would be if the problem asked us, for example, how much am I not paying? I'm not paying 20%. What's 20% of 80? So that would be basically this kind of problem. It would basically be like asking, what's 20% of 80? Problem number 3. Problem number 3 says, I paid 27 euros for a jacket that had a 10% discount. How much would the jacket have cost without the discount? So in this case, we know that the discount is minus 10%. That's the change, which means that in the end, we pay 90%. We don't know the initial price before the discount. All that we know is that in the end, we paid 27%. This is what we're looking for. We are looking for what the jacket cost before the discount. Again, though, the method of solving this is the same. Take the cross product. And you can only take the cross product of things that are on the same lines. So this and this line. You couldn't do, for example, let's say this with this, because 10 and 27 are not on the same line. So you need to take 100 times 27 needs to be equal to 90 times x. So we get that 90x needs to be equal to 100 times 27. So 90x needs to be equal to 2,700. Divide both sides by 90, and what we get is that x is equal to 3. That was the initial price. Initially, the jacket cost 30 euros. So the jacket would have cost 30 euros. Next, we have a problem that says, I bought a game that normally cost 50 euros for 35 euros. What discount did I get? In this case, we know how much the game initially cost, 50 euros, and we know how much we ended up paying. We paid 35 euros. What we don't know is the discount or how much we paid. So my unknown is basically here. Now, you might be thinking, okay, cross product. But again, I can't take cross product if everything isn't on the same line. So right now, x and 35 are not on the same line. So I couldn't do this, for example, because x and 35 are not on the same line. So what I need to do is find this, how much I didn't pay. This discount is basically saying I didn't pay a certain percent of the game. Well, how much didn't I pay? How many euros did I not pay? It's the difference between these two. The difference between 50 and 35 is 15. I did not pay 15 euros. And now we have things that are on the same line. So now I can take this cross product. And what I get is 50x needs to be equal to 15 times 100. If I, not yet, sorry. 15 times 100 would give me 1,500. And if I divide both sides by 50, what I would get is that x is equal to 30. So my answer should be that I got a 30% discount. That's all for today. See you guys again tomorrow.